Hello, my name is Michael Clark. I'm an IT operations and tech industry consultant with Renaissance Tech and Media, where we help companies and organizations struggling with cybersecurity challenges to operate more safely, securely, and efficiently in the world of hybrid multi-cloud computing. Today, I'm here with Brett Hamill, Senior Soft Solutions Architect at Genians, a company that has helped over 1,600 customers around the world since 2005 to secure their network edge with next-gen network access control. Also joining us today is Naveen Rohatgi, co-founder of Seceon. Seceon's AI SIEM provides enterprise-wide security intelligence with machine learning and threat detection to its global customer base. Mitigating risk in today's threat landscape has proven to be an extremely challenging task for security professionals everywhere. A recent IBM analysis found that cybersecurity teams use over 80 different security products from 40 different vendors on average in their customers' environments. Now, conceptually, we all know that an integrated approach is the best for detecting and mitigating cybersecurity threats. But how can we orchestrate the activities of these individual cyber solutions most effectively? How can we most efficiently maximize our cybersecurity resources without drowning in a sea of complexity? With network access control capable of locating and controlling any non-compliant or compromised devices at the network edge, it serves as the key component necessary for establishing an effective cyber defense framework. It can also orchestrate an organization's security products by integrating them with a wide range of IT security solutions, from IPAM to next-gen firewall, IDS, IPS, SIEM, and so on, to ensure unified policy enforcement. Today, we will discuss how Seceon and Genians integration enhances the ability of Seceon AI SIEM threat detection with zero-touch, vendor-agnostic, Layer 2 ARP enforcement capabilities of cloud-managed Genian NAC. The result is the ability to isolate devices identified as a threat at Layer 2, blocking both internet and local traffic and displaying information to the end user via a captive web portal. This both secures the network at the point of connection in real time as new threats are detected and educates end users regarding the security status of their devices. So with that, I'm now going to turn things over to Brett Hamill to begin our conversation.
Thank you very much, Michael. And for those who are following our webinar series and have seen previous webinars, we appreciate you returning. For those of you joining us for the first time, we hope you enjoyed today's webinar. As Michael advised, we'll be answering questions at the end of the webinar. A quick look at the webinar topics for today. So today we will be giving an overview of the Genian NAC solution and its multi-layered network access control capabilities. Seceon will also be giving an AI SIEM overview of that product, including the comprehensive security platform features that that product provides. We'll be looking at a correlation of all events between the two systems, looking at user and entity behavior, cyber threat detection, device identification, and device grouping and policy enforcement. Last, we'll be looking at how this information is turned into actionable intelligence that provides network security automation and auto remediation, followed by a brief live demo of the integration itself. Let's start off by taking a look at the Genian NAC product. Before we dive into exactly what Genian NAC is and how it works, let's talk about how NAC plays a role in any cybersecurity plan. 3 critical steps for cybersecurity include surveillance and visibility, control, and also automation. For those of you that may have seen previous webinars, we did deep dives on topics of surveillance and visibility, as well as control. Today's webinar is going to focus specifically on automation. By implementing these controls, the Center for Internet Security has advised that you can defeat over 85% of the most common attacks. So this is why network access control is key for these basic controls and a critical component for any cybersecurity plan. The reason being is if you look at these basic controls that are recommended for various regulatory compliances across the board for different vertical markets in different areas of business, you'll note that these can be lined up directly with features of network access control. So keeping these basic controls in mind and knowing that these have to be addressed and these are some of the most basic recommendations, we'll look at the features of network access control and how they line up with these requirements. So we have the core cybersecurity requirements on the left, network access control on the right, and we have a direct one-to-one correlation between these requirements and the feature sets that network access control can provide. We covered the inventory for hardware and software in previous webinars, and that NAC can detect all IP-enabled devices on the network and collect information about installed hardware, software. Additionally, we previously talked about the controlled use of administrative privileges and how devices can be authorized and users can be authorized based on various criteria, and NAC can assign privileges that way. And then we also talked about the secure configuration for hardware and software on various devices and how NAC can inspect those devices' configurations and maintain a security baseline. So the other two highlighted items today, 3 and 6, we're going to focus on in this webinar. That is continuous vulnerability management and how we can leverage the network security automation and the integration we're going to be looking at today to manage devices affected by vulnerabilities or identified as threats. Also, how you can monitor that in real time, analyze those logs, have an audit trail, and have real-time logging, reporting, and actionable intelligence based on that information. Network access control. So when you talk about controlling devices on your network, once you've discovered those devices, and again, for the deep dive on visibility, you can visit genians.com/videos to look at past webinars where we talked about visibility. Once you've identified those devices, though, you then need to group them together. With Genian NAC, you have over 500 predefined conditions to make granular grouping possible. Then policy enforcement can be based on the endpoint compliance status and based on what grouping nodes are matched into. And then finally, you assign granular permissions based on what you've discovered through the policy enforcement matching. How you do that will vary. With Genian NAC, you have multi-layered security, meaning you have multiple implementation methods as far as network architectures and NAC architecture and how those two integrate. Today, we'll be focusing primarily on the ARP enforcement technique with a network sensor. This takes us into how does Genian NAC work. So looking at the various network NAC architecture comparisons, we can see that there's different ways to implement NAC. So these implementation methods represent the vast majority of all network access control implementations in use today. Genian NAC supports all of these methods, but today we'll be focusing on this network sensor architecture. If you look at this matrix, what it tells you is that these types of implementations and architectures go from the most complex to the least complex. When you're talking about a radius implementation, which is very common, but one of the most complex integrations out there today, some of the challenges you have is the fact that you have to update every switch, you have to add all your switches to radius, you have a single point of failure, high availability is typically required because of that. Vendor agnostic is actually not true because there are radius requirements for those network devices. You have minimum switch and controller features that are required for that integration. Downtime is a yes with a high risk because you actually have to enable authentication for radius. And when you do that, if anything is misconfigured or it hasn't been validated ahead of time with an opener monitor mode, you're basically implementing something that can actually take the network down. Also, once you actually reconfigure, or if you do a full network refresh, at that point, you may have to reconfigure all devices on your network. Throughput and capacity concerns, you may be dealing with that with Radius, but some of the other implementations like Mirror and Span introduce that. Then you have to look at whether or not you can have a cloud-managed solution, if it's zero or low touch, if you need to have a system at every location, and if your hardware, if you need hardware, can be applied at small form factor, very cheap, inexpensive hardware. So we'll be focusing on the sensor NAC architecture today, as we see that as the most beneficial architecture, and most of our customers use that architecture. With the Genians ARP enforcement architecture, essentially the components that are applicable are your policy server. That policy server can be hosted in the customer or on-prem data center or in the Genians cloud. One of the key factors here is that you have no requirements for the network environment, so it doesn't have to support radius or any other features. Additionally, you actually don't have to configure your switches, controllers, or access points for this implementation. Because this system fails open, high availability is not required and typically not deployed. This is truly vendor agnostic because there is no requirements based on any specific vendor or no dependencies based on any specific vendor. ARP is truly vendor agnostic across all vendors. This system can also be rapidly deployed with approximately 10 minutes per server sensor combination. The sensors will sit on various areas of the network, depending on your network topology, can simply be connected to a trunk port, and can monitor all VLANs that are tagged on that trunk. Sensors are implemented by default in a passive mode, monitoring passively all traffic on the layer 2 segments that it has visibility into, and active or enforcement mode is when it will actually manipulate ARP traffic and either quarantine or redirect traffic to the network sensor depending on your policy configurations.
Thanks very much, Brett. We're now going to turn things over to Naveen to provide us with a brief product overview of Seceon before we then follow up with the section covering Genian Seceon integration. Naveen?
Thank you, Michael, and all the attendees. Let me start with a brief introduction of the company. Seceon came into existence back in 2015 with a clear vision of cybersecurity done right. The ML and AI automation, I repeat, not signature or rule-based, are the core mantras of our solution since existence. Since 2016, Seceon has won more than 50 awards. Coming back to slide number 1. Seceon AI SIEM delivers a comprehensive cybersecurity platform for the digital era that not only gives you all the SIEM functionality that you expect from a traditional SIEM, such as log aggregation, indexing, searching capabilities, etc. Apart from that, you also get real-time threat detection and remediation through our SOAR functionality and through our ML and AI capabilities with actionable contextual awareness. Unlike the siloed solutions, Seceon's platform was built ground up using the latest and greatest big and fast data technologies. It gives us the unparalleled scalability and edge over our competition. And it also allows us to detect threats in real time using in-memory computation. So what it also does is automates a lot of mundane work a SOC analyst has to do, such as writing rules, sifting through the thousands of alerts, taking remediation actions, etc. Making it the industry's first fully automated solutions offering proactive threat detection, containment, and elimination for all threats, including but not limited to cybercrime, such as malware, insider threat, UEBA, DDoS, vulnerability exploits, industrial IoTs and IoTs, IDS, and NBAT. An example of auto threat detection and remediation would be a host identified with a malware infection. Seceon SOAR module will push a policy to the firewall to block communication with the malicious IP, and to the NAC to quarantine the host. In the same flow, an insider threat can be remediated by disabling credentials of the user and forces that user to be logged out via Windows AD. And last but not the least, the solution also provides continuous compliance. The way we differ, if we not only provide the compliance report at the end of the month, but also getting informed for any violation when it happens. Once again, providing you information in real time. So here, what you are seeing is at the high-level overview of our solutions functions. Left-hand side, what you are seeing, all the different sources from which we ingest the data. I want you to pay a close attention to second bullet item, where it is ingesting the net flows, IPFix, and S flows. That is something which is quite unique to us when we started this company. At that time, most of the SIEMs out there were just consuming the logs, which provides you only half of the picture. Hence, Seceon AI SIEM consumes both the logs and flows to see and correlate both host activities via logs and network activities using flows. The resulting combination provides better correlation and better alert quality. Our ML module creates a behavior profile of each and every host and user in the network, and flows plays a major component in completing that profile by adding the communication patterns such as applications being used, who is communicated with whom, etc. It gives us an unparalleled visibility and making our AI models much, much more richer and superior to that competition totally ignored. So in addition to these flows, we have the capability to ingest the logs from various identity management systems such as Windows AD, LDAP, OpenAM, etc. that helps us to monitor the user behavior such as login profile, account creation deletion, privilege escalation, etc. And then with our solution, we are able to protect both your on-premise and cloud deployments. The beauty of the solution is to provide a single pane of glass where you're able to see the complete organization, whether in cloud, on-premise, or spread across multiple continents, etc. You see everything in one place. That is what I call a comprehensive visibility. So that is on the ingestion side. So once the data is ingested, we filter out security events and normalize them and perform contextual feature enrichment such as geo enrichment, that is which country this IP belongs to, threat intelligence enrichment, whether the IP is blacklisted or not, application enrichment such as Facebook or Dropbox, etc. Once the events are contextually enriched, they are fed into our machine learning module, which checks for the behavior deviation from the past learned profile and raises threat indicators, which are then fed to the dynamic threat models, which eliminate the need to define the rules. One of the biggest costs of operationalizing a SIEM is spending time on defining the rules. Any other SIEM would on an average have more than 500 rules. And as you add, remove, replace a new IT device in your organization, you need to add, remove, modify, and enhance your existing rules. Once again, a big operational cost. Seceon AI SIEM do not require you to write the rules. Now on the output side, you get 360-degree visibility based on both network and host activity, glued or correlated together. So you don't have to go and get this information. We bring it together for you. In addition to, you get proactive threat detection based on behavior analysis in real time, and you can remediate or nip the threat during its budding phase itself before it becomes a major infection. And we will demonstrate this capability today. And last but not the least, you get the continuous compliance and reporting. As you expect from any modern SIEM, our UI is built on the modern infrastructure and modern methodologies and modern design patterns. So here we have a sample of our dashboard, which provides you a quick view of the security posture of your organization. One of the value add of the Seceon AI SIEM is prominently visible at the left top corner of this dashboard. At the left top corner of this dashboard, which is at the top here, you can see there are 88 million events that this SIEM is processing. And out of those 88 million, 450,000 of them are threat indicators, which many in the industry also calls them as indicators of compromise. After going through all those threat indicators, which are generated from the logs, from our flows, or from our machine learning, they go into our threat models and our correlation engine, and only 16 of them are turned into an alert. So what I'm trying to say again here is that 88 million events are generating only 16 alerts, which is the biggest difference that you can see. Another thing that this dashboard is showing you is the total number of applications we are monitoring, the total number of internal private hosts we are monitoring, in this case 201, and their communication to the various public hosts, which in this case is 9,000. Along with that, another part that this screen is showing you is alert screen. In your alert screen, you can see how we have been able to prioritize the alerts and show you the critical and major alerts. So it also helps you in giving you information about the alerts and the drill down capabilities that you get. When you drill down into those alerts, you'll be able to see how we have correlated various threat indicators and bring up this alert for you.
Thank you, Naveen, for providing that overview. Brett is now going to discuss further how the two systems integrate before we jump into our live integration demo.
Thank you, Michael. Thank you, Naveen. So continuing along with the theme of events and correlation of events, here you'll see a Genians dashboard. Will show information about what types of platforms, how many of those platforms are on the network, how they've been categorized, what their enforcement policy status is, how those devices are connected, et cetera, et cetera. So that's a highly customizable dashboard that can display any information you want through 130 widgets that you can use to customize that dashboard. The underlying data that you see behind that in the other screenshot is really the information that is going to allow us to extend the Seceon capabilities into layer 2 enforcement, because Genians is tracking all information about that particular device relative to the network, the IP address, including IPv6, MAC address, other information, location, where it is physically connected to, what port, what SSID, etc. And then we're also tracking platform information, which we've talked about at length in previous webinars. So this information, along with all the other information that Naveen was going through in the previous slide, is what is the key to success for the integration itself. So we refer to this as actionable intelligence. So having tons of data is nothing but tons of data, right? As Naveen touched on a moment ago, millions or thousands of alerts and massive reports are just not scalable, right? So how can you take that intelligence that you've gathered and make it actionable? So the Seceon AI SIEM, tracking security events, looking at user and entity behavior, and generating alerts based on that behavior, and then the information that Genian NAC collects relative to the network surveillance and visibility it has, the who, what, when, where on the network, and the ability to, regardless of what type of network you have or what vendor you have deployed, to be able to use an agnostic enforcement method to actually enforce policy. That is the key to having that intelligence being actionable. So the highlights of the integration before we actually look at the demo include extending Seceon's AI SIEM capability use those security threats that are forwarded to Genian NAC, and then leveraging the zero-touch vendor agnostic layer 2 quarantine capabilities, you can actually block external and internal traffic real time. If you compare this with some other legacy threat detection and quarantine methods, the advantages of being able to enhance a solution like the Seceon AI SIEM with a solution like Genian NAC becomes clear. So if you take any type of collection engine that is generating any kind of threat information, you have several different options out there. These are some of the most common. So if you generate only alerts and you don't have any other way to do anything with that information, of course, that's very manual process, resource intensive. A human has to go through those massive reports. If they remediate something, it's not real time. So it simply just doesn't scale. If you send those alerts to a next generation firewall, it adds benefit. It does add some benefit. It will be platform dependent, depending on how that firewall can ingest that information. And then also, you're blocking typically internet traffic only. So ultimately, that leaves the network vulnerable. Your east-west traffic is exposed, oftentimes including inter-VLAN and same segment traffic. If you send those alerts to a radius NAC-based system, you have all the challenges that we looked at earlier in the architecture slide with the complex integrations. You have vendor dependencies, single point of failure, high availability, and a lengthier time to actually deploy that kind of a solution. If you send those alerts to a layer 3-based NAC system, maybe if you're port mirroring or spanning, you have load and capacity concerns. The TCP reset enforcement capabilities does have some limitations. Not all traffic, UDP traffic will be blocked, and your local segment ARP traffic is simply unchallenged. You could use an agent or a plugin, and you use that endpoint enforcement option. That works typically on certain platforms. So for BYOD or IoT environments, that may not be friendly to that environment. And typically there's some increased cost when it comes to that type of solution. And also if you block it Active Directory, sometimes you have an agent or a connector that's required, which could cost more. And again, BYOD and IoT, if they're not participating in Active Directory, there's some vulnerability there. So you still have a vulnerable network using that enforcement approach. So the benefit is if you combine Seceon AI SIEM and Genians for security automation, really what you're doing is you've got this Seceon AI SIEM correlating and monitoring not only device activity, but user behavior. As soon as it goes through and correlates and siphons down those threats down to actual alerts, they're sent over to a Genian NAC. Genian NAC will then perform real-time layer 2 quarantine using ARP enforcement. So what that means is whether you're on a wired or wireless network, regardless of the network infrastructure or your method of connecting, we're able to do immediate layer 2 quarantine, and you don't have to worry about all sorts of mechanisms or levers on the network to enforce that. So now all of your east-west traffic is blocked, including same segment traffic. Additionally, this integration can be configured in minutes because it is not very complex. Okay, so now we're going to switch to a live demo. First, we're going to take a look at the APE UI for the Seceon AI SIEM. So this is the main dashboard for the Seceon SIEM, and essentially what we've got here in this demo system is it's collecting events, siphoning those down to threats, and then generating alerts. So what we're going to do in this demonstration is create some device or user behavior that will result in an alert, trigger a notification to Genian NAC, and ultimately result in the quarantine of that endpoint. Next, we'll take a look at the Genian NAC UI. So the information you're going to see here is going to be similar to the information we saw in our last slide, which is information about all the devices that are actually on this test network. And they're categorized. There's information regarding what enforcement policies devices are applied to at the moment. And then we're going to show our actual test device in this list. So here, of course, is all of the information that Genian NAC is collecting about these nodes. And then we have this particular device right here, 55.34, is going to be our test device, presently matched on the default policy, which is a permit all policy. So this device has network access at the moment. Now we'll go over and we'll take a look at the device itself. Here's the device in question. We're going to generate a ping to an internal node on the same network. We're also going to generate a ping north-south out to Google. Of course, we'll verify here that this has network access, which it does. What we have here is the ability to simulate some malware traffic. So in the bookmark, I have a blacklisted site. So this is a blacklisted site that is included in the Seceon database as an unauthorized site. When this node tries to connect to that site, what's going to happen is, you'll recall Naveen talked about the different methods of ingestion from the network. So you have the Seceon AI SIEM is taking flows and other information from the network into its correlation engine. And when it takes that information in, it's going to siphon it through all of its AI correlation methods, and it's going to determine if that's an alert. So it'll take roughly a minute or so for those flows to get exported from the network over to Seceon, and then maybe another minute to two for Seceon to go through and make sure, right, that this is an alert worthy of applying a remediation to. When it gets done with that, it'll actually post an alert in Seceon SIEM, and it will then send the corresponding syslog event alert over to Genians. Genians will then perform a layer 2 quarantine of this device. The way that's happening behind the scenes is, as this device tries to access the network, Genians is going to actually respond to ARP requests and going to either redirect or block traffic, depending on the traffic, over to Genians. This is with no integration with the network infrastructure, meaning we haven't configured switches or any wireless equipment in order to enforce this policy. So we can see now here the ping starting to drop. So that's fully automated remediation. So now we have 2 ping tests that are going, one to the north-south traffic, one right on the same local segment, and that has dropped. Additionally, there's an optional captive portal message that can be configured. So here what you see is a note that can be customized, and this is to help educate and advise your end user community that there's been some type of a threat detected. So this can be customized. You can have all sorts of buttons and logos on this board, but this lets this end user know something has happened and they need to take an action. At the same time, instead of just blocking traffic at the firewall, which is what a next-gen firewall integration would do, we've blocked this layer 2 traffic. So let's go take a look and see what made this integration work inside of the various UIs. So if we go and we look at the node in question, the 55.34 node inside of Genians, we'll now see that it's no longer part of the default policy. It has Seceon threat quarantine policy. If we actually look at that policy, we can see how that policy is structured and see how this enforcement worked. So here it is. Here's the one node, which is our node in question. Click on that. It'll take you to details of the node. But if we look at that policy and we check the structure of that policy, we can see what options we've implemented with this policy. So we can prioritize it, enable it. So the way this policy works is there's a security tag that's applied, and then you can assign permissions. We've poked a couple of holes so we could do our demo, but aside from that, we're dropping all traffic. We've also enabled captive portal here. So that is why you saw the device blocked and the captive portal message displayed. The way that the integration works is there actually was a syslog event that was received from Seceon, and that event is here. And inside of this event, there's information that this IP was deemed as a threat. This event correlates to an action inside of Genians to apply a security tag, which then ties it to the permissions. Now we'll go take a look inside the Seceon's UI. We'll go into the alert section. You'll notice here there's no open alerts. That's because auto remediation is enabled. If this were an open alert, then someone in the SOC would have had to have gone in and manually remediated it and have been a bottleneck, and it would have taken longer, and you have to staff up to be able to handle that kind of situation. So we're going to look at remediated alerts instead. Toggle this. Look at the last 15 minutes. There we go. So there's our alert, and this tells you that this device was suspected to be infected with malware. This is because it visited the blacklisted site that we simulated user traffic for a moment ago. So this was actually what generated the syslog alert to Genians, and that's what actually resulted in the layer 2 quarantine of the endpoint.
All right, nice job. Thanks very much, Brett. We've got some questions, so let's take a look at those and see if we can clear up any mysteries here. The first one is someone asking what other actions Genians can take if a device on the network is identified as a threat.
Okay, this is Brett. I'll take that question. So if we look inside the Genians UI and we look in the enforcement policy itself, in addition to the default method of ARP enforcement, there's additional actions that you can take. So you can actually do SNMP switch port blocking. So you're able to actually shut down the switch port using SNMP if you would rather do that instead of ARP enforcement. On top of that, you can actually do radius COA. And when you actually do radius COA, you can assign different kinds of vendor-specific attributes. So you could select the VSA and you could send something back here like a VLAN or a downloadable ACL or any kind of attribute that you would like to send. Additionally, you could do an agent action if in fact you had agents deployed, and then you could configure whatever kind of agent action you want. In this case, we don't have one configured. So there are different things you can do when it comes to how you can quarantine the device and what action you can take when that alert is received from Seceon.
Right, so we see the integration there in real time. Someone is wondering about Seceon being deployed in the cloud. Please confirm.
Yeah, I will take this question. This is Naveen. So yeah, Seceon can be. This is a good question, and let me just give a brief overview of our architecture. We have two components. One is called as CCE, and another called as APE. CCE is collection and control engine, and APE is analytics and policy engine. The job of the CCE is to collect the logs and flows, and the APE is running all the other modules. Both CCE and APE can be deployed in the cloud. You can deploy it in both Azure as well as AWS clouds. CCE can be in the cloud to collect the logs and flows from all other cloud devices that you may have in your network. Like you can have VPC logs collected from the AWS cloud, which is the communication or kind of a net flows between the various devices. So you can have a CCE in the cloud and APE on-premise, or you can have both CCE and APE in the cloud, or you can have APE in the cloud and CCE on-premise. So all combinations are possible. Thanks.
All right. We've got one more, someone inquiring as to how difficult it is exactly to configure Genians to process alerts from Seceon. Can we recap again the steps that are required there?
This is Brett. I'll take that question. So one of the things we talked about was how easy it is to set this up. So you don't have to configure complex API queries or really in-depth integrations to make this behavior work the way you saw today for this integration. So underneath the configuration here, there's actually a remediator option in the Seceon APE UI. And in order to enable auto remediation, all you have to do is add your Genian NAC device. It falls under a subset of the firewall category. Give the IP and some other information, click save, and now you have added the Genian device to this solution, to this configuration. On the Genian NAC side, inside of here, you just simply set up a log filter. So in the log filter, Seceon threat detected, there is an action every time this particular type of alert is received. So inside of here, you'll see that it actually adds a security tag. So if this verbiage is received from Seceon, it will add the security tag, and the security tag is what links it to the enforcement policy that we saw earlier. And the enforcement policy, Seceon Threat Quarantine, is what assigns the permissions. That's it. A few minutes on each side to actually set up the integration end to end.
Yeah, so very straightforward and very nice. Thank you both, Brett and Naveen. That actually completes our Next Gen NAC with AI-SIEM webinar for today.